Hi guys, today we're just going to quickly go over some of the stuff we learned in transition last year about the difference between a function and a relation, and then these two other words, mappings and correspondences, which we'll try and clear up some of the confusion around those. So first off, what's a relation? Let's just remind ourselves. A relation is just where you have any two sets and you've got some relationship between them. There's no better way to say it, really. So for instance, we might have the set of students in a year level, and we might have all the subjects that they do, all the subjects in the year level. Those are our two sets, and then our relationship might be as simple as which subjects does each person do. If Julia does methods, that gets a relationship. If Robbie does literature, that gets a relationship. So that's the relation is as general as you can possibly be. Alright, so we sometimes write these things as what we call mappings. So a mapping is really just a way of representing the relationship. So the relationship is kind of the high level conceptual name for it, and the mapping is kind of the nitty gritty of how do we pair these things up. So we can do lots of things. We could write down our relationship in lots of different ways, and you can be quite creative about this if you want to be. But the most common are either with an equation, down the bottom here. That's if the two things are numbers, then that's usually the best way to go. If not, if they're just categories, if they're just things, then usually ordered pairs are the way we do it, and we just write down all the possible sets. But you could imagine that could get pretty tedious if there's lots and lots of things in both sets and there's lots of relationships between them. So sometimes we might take a shortcut and just use some sort of rule, some definition, and however you want to define it. If the easiest way to do it is to use an equation in maths, then fantastic, but it might just be a worded relationship. Now, of course, we usually in methods are going to be caring about relationships between sets of numbers, so we're going to be sort of dealing with the bit down here more often than not. Okay, now a relationship, you'll notice, goes both ways. So there's a relationship between Julia and English, but there's also a relationship between English and Julia. It's kind of symmetric. Julia is a student in English. English is a subject that Julia does. So some things like that, you could ask, like, what's Larry's favourite sport? And you might say cricket. But you could also say whose favourite sport is cricket, and you could say Larry. But notice that those two questions aren't exactly the same, right? What is Larry's favourite sport only really has one answer. Like, you may know the answer or you may not, but there's only one answer to that question. Whose favourite sport is cricket? Well, you'd have to say like half the population of India, and also Larry, and also Mr. Malone. So there's lots of different answers to this question. There's only one answer to this question. Questions of this sort are called functions. Okay, so a function is a relationship that has the special property that it maps one thing unambiguously to one other thing, and it only has one answer. So in our previous example, this is not going to be a function, because if you plug in Julia, you get 3 or 4 different answers. You get methods, you get physics, you get English. You don't just get one unambiguous answer. What's the subject that Julia does? Oh, it's physics. So that's not going to be a function. This type of relationship here is what we call a many-to-many relationship, and we've got a whole other video on the difference between many-to-many and many-to-one and all this sort of stuff. But many things here map to many things here, and it's all over the place. Many-to-many relationships are not what we call a function. A function is more like something like this. So we have our same students over here, that's our set from before, but this time we're going to ask what's their hair colour. And that's an unambiguous question. Each person only has one hair colour. Well, if you define the hair colours creatively enough. So this is going to be a function. If I ask you what colour hair does Julia have, the answer is brown. She doesn't have brown hair and also blonde and also this and also that. So this is a many-to-one relationship, which is a function. Now, of course, we usually care about functions and relationships between numbers, not between people and subjects. So just about everything we've come across so far in maths is actually an example of a function. So linear relationships in Year 9, quadratic relationships in Year 9 and 10, cubics that we've been doing earlier this year. All those things are types of functions. If I give you an x value, you can give me a y value. And some of the things you saw in Year 10 around compound interest or something, that's a type of function, because if you plug in a certain amount of time, 5 years or whatever it might be, you can tell me how much money do you have after that amount of time. So it's got a single answer. You plug in an argument. Oh, I've thrown in a word there. Argument is the thing that you plug in, and then you get out an answer. Even trigonometry, which we don't think of in this language usually, that's an example of a function, because if I give you an angle, you can give me the sine of that angle. But notice that these things only work in one direction. So if we think about the quadratic relationships, if I give you an x value, you can give me a y value. But if I give you a y value, quadratic formula has that plus or minus in it. And that means there's not one unique x value that does the job. So that's not going to be a relationship of a function if we're trying to go the other way. Quadratic relationships are examples of functions only from x's to y's. So you always have to be a little bit mindful of what's the thing that I'm plugging in and what's the thing that I'm getting out. Okay. We summarize what makes something a function using a thing called a vertical line test. And a vertical line test is just what it sounds like. So here's an example of a type of relationship between two sets of numbers. So here are my x values here, and they're getting mapped onto some y values here. And this red line represents all the ordered pairs, all the possible combinations of numbers which satisfy some equation that it's defined by. How do we know if this is a function or not? Well, what we want to do is imagine taking a vertical line and just dragging it along here. And if it only ever cuts the graph once, then you've got yourself a function. Because that means any x value you want to plug in only gives you one unique y value. An example of something that's not a function. Here we go. We can take that vertical line, and if we run that back and forth across here, it looks like a function, looks like a function, looks like a function. It doesn't give us a unique answer because the same x value is producing multiple y values. So why is that important? Well, imagine that you're writing a computer program or something and you want to put in some inputs and you want to predictably get some outputs at the other end. Well, you don't know, if you write this program and you put this equation in there, then you don't know which of these answers you're going to get. So if you want predictability, then what you want is functions. So this thing here fails the vertical line test, which means it's not a function. Now, you guys know that we can actually recover this as a function by limiting this domain over here. If we just only want to work in this region here from up to about -2 or whatever that point up there is, then we could say, okay, it is a function, but it's only a function if we restrict the domain. And we'll do a whole video on what it means to restrict a domain and what a domain is and so forth. So just briefly back to the terminology. And relation is any relationship between two sets of things. So if you can imagine any rule that relates two sets to one another, that's a relation. A mapping is just the name we give for the rule itself. And we talk about one set being mapped onto another set, or we talk about a mapping from one set onto another. So it's kind of just the verb version of relation. We can also talk about an element of one set, a particular thing being mapped onto some other element. So we can talk about Julia being mapped onto English, or Julia being mapped onto methods, or 5 being mapped onto 25 in y = x squared. A function, just a special type of relationship where each element in the first set only maps onto a single element of the second. So we talked about that a bit, vertical line test, etc. And a correspondence, that's a word that you'll see come up a little bit. It's really annoying that we have all these different words for the same thing, but it's just another word for mapping. We usually don't talk about a correspondence from a single item, though, a single element. We talk about the correspondence between the sets themselves. So usually you're going to see this word correspondence when you're talking about one-to-many and many-to-one and many-to-many and so forth. And that's pretty much the only place you'll see it, but it's really just another name for a relation. Okay? And that's the lot. Thanks for listening. Bye.